Hello, everyone. Welcome to Physics 521. This is condensed matter physics. My name is John Nickel, and I will be the instructor for this course. I am an experimental condensed matter physicist by training, and my research focuses on individual electron spins in semiconductor quantum dots. I wish we were all meeting in person this term, but due to the pandemic, this course will be online, and we will be using an asynchronous format. That means that I'll be recording these mini lecture videos beforehand. I'll post them to YouTube, and you can view them on your own time. More about that in just a little bit. I'm happy that you're all taking the course, and I hope we have fun and instructive time together this semester. So this first mini lecture is just an introduction to the mechanics of the course. Today we'll go over the syllabus and talk about some of the basic motivation for studying condensed matter physics. So let's start with the syllabus. I'm going to switch to sharing a PDF of the syllabus. Here it is. So as I said, my name is John Nickel. My email address is john.nickel@rochester.edu. As I said before, this course will be entirely online and asynchronous, so I'll say more about this in just a little bit. We will meet periodically on Zoom. Here's the ID for that recurring Zoom meeting, as well as the password. In general, I will be on Zoom in this meeting during our regularly scheduled class times of 9:40 to 10:55 a.m. on Tuesdays and Thursdays. So this course will, as I said, cover the basics of condensed matter physics. We'll begin to answer some questions like, why are some materials good electrical conductors while some are not? Why do some materials superconduct? Why are some materials semiconductors? What does it mean for a material to be a semiconductor? And why are some materials magnetic and others not? So we'll go over things like the Drude model, Sommerfeld model, crystal lattices, Bloch's theorem, band structure, phonons, semiconductors, magnetism, and superconductivity. So the textbook for this course is Solid State Physics by Ashcroft and Merman. So this is a rather old textbook, but it is quite good, and I encourage you to buy it. It's one of these textbooks that gets better and better each time you read it. So this will now be my fourth or fifth time through this book, and I enjoy it and learn something new from it every time I go through it. So there are some other good references that you could consult for this course. One is Introduction to Solid State Physics by Cattell. This is written at a somewhat lower level than Ashcroft and Merman, and Condensed Matter Physics by Marder. This is a very large, very complete volume. You may also find it useful. So let's talk about the format for the course. As I said, this course will meet entirely online this term. And this will also be asynchronous. So that means before each class period, I will post several video mini lectures beforehand. And you should ideally view them and take notes of them before each class period. So we don't have to meet on Zoom every day, although I'll be online on Tuesdays and Thursdays. You can think of that as my office hour. I'm going to ask that we meet on Zoom every Thursday at the link above here. Here it is. Just to touch base with each other. So again, we'll meet every Thursday at 9:40 in the morning at that in that Zoom meeting, just to touch base. So on the first day, which will be August 28th, we'll introduce ourselves and just talk a bit about the course. On the following Thursdays, what I'll ask is that each of you come to that meeting with at least one question that you've come up with that has to do with the material for that week. So I'm going to require that you come to these meetings. Part of your grade will be based on this attendance. And at these meetings, we'll talk about the questions. I'll answer the questions. I hope that I can, and we can discuss them as a class. And as I said, your attendance at these meetings will count for 10% of your grade. So the grade for the course will be based entirely on attendance at the Thursday Zoom meetings and also homework sets. So that attendance will be 10% of the grade and the homework will count for 90% of the grade. So there won't be any exams in the course. There will be a number of homework sets given. I'll post them in the learning modules folder on Blackboard. By the way, let me emphasize that all of this material, and in fact, all of the course material for this course will be posted on the Blackboard website, which you should all have access to. You should absolutely discuss homework with your classmates in a socially distanced manner. You need to write up your solutions on your own. And I'll ask that you email me the solutions to the problem sets by 11:59 p.m. on the due date. So I will not accept any late homework. Don't test me on this. I will not accept any late homework. This comes up almost every term. Let me repeat again. I will not accept any late homework. This is a graduate level class. I expect that you all should operate at the level of graduate students. Since there are no exams, doing the homework properly and on time is very important. So when you email me your homework set, please use P521 HW as the subject line. And at the end of the term, here's how I will assign letter grades for the graduate students. So roughly 90 to 100% is an A, 80 to 90% is a B, 70 to 80 is a C. Anything below 70 is an E. Again, a great way to get a good grade in this class is to do all of the homework thoroughly. A great way to do poorly in the class is not to turn in some or all of the homework. And again, don't test me on this. I will not feel bad about giving bad grades if you do not turn in and do all of the homework assignments. I will make sure to return your homework assignments to you before the next one is due. So I'll post the course schedule on Blackboard. So this will include for each nominal class period, again, though we're only meeting on Thursdays, links to the mini lectures and topics. So links to these mini lectures, which will be on YouTube, will appear on the course schedule page in Blackboard. Again, I encourage you to watch the mini lectures and take notes before each class period. It will be up to you to get the most out of these, so I encourage you to stay on top of this and to watch them as they come out. Again, I'll host a Zoom meeting during each scheduled class period. That's 9:40 to 10:55 on Tuesdays and Thursdays. Those will be my office hours. I'm happy to talk about any of the material or homework assignments or anything else related to the class. Again, we will meet all together, if only for a few minutes, on Thursdays on Zoom to discuss your questions. It's important that we're all honest academics in this course. So you can find more about the academic honesty policy at the university from these links. In particular, what this means for the course is that you should certainly feel free to discuss the homework problems with your classmates, but you must write out the solutions on your own. You should not copy solutions from one another. If it seems that this is taking place, your grade will suffer. And if you need any accommodations, please do not hesitate to reach out to me, and we will take steps to ensure that those accommodations are met. So again, the syllabus is posted on the Blackboard website. Here's the textbook for the class, Ashcroft and Merman. All of the homework problems will be taken out of it. Grading is based on homework and attendance with a question at our Thursday Zoom meetings. All right. If you have any questions, of course, please feel free to reach out to me by email, or there are a number of options to do this on Blackboard as well. So let's go back to the whiteboard. So those are some of the basic mechanics of the class. So now let's just talk a little bit about condensed matter physics in general. So one of the themes of this course is the notion that more is different? So this is a famous saying in physics. Do you know who coined this phrase first? So this was Philip Anderson. He was a very famous condensed matter theorist. First, he worked at Bell Labs, and later he worked at Princeton University. So why is this a good phrase to think about condensed matter physics? Well, condensed matter physics, or solid state physics, as it used to be called, really deals with the properties of very large numbers of particles. So although you and I understand what happens to individual atoms quite well based on the theory of quantum mechanics, um, it's very difficult for us to understand in any kind of precise or completely accurate way what happens when we have 10 to the 23 interacting particles in the same place. And in fact, as you know, new behaviors emerge when you have systems with this many particles. For example, you don't really think of an individual atom conducting electricity, but you know that when you have 10 to the 23 atoms of a metal, like gold together, that large chunk of material can indeed conduct electricity. Why does it do this? This is not a property of the individual atom, yet it's something that emerges when you have more than just one of them. So here's a great example of why more is different. You can also ask questions like, why are some materials shiny? Individual atoms aren't shiny. Why is a material shiny? Why are some materials magnetic? Why do some materials conduct heat? Why do some materials superconduct? These are all properties that emerge when we have very large numbers of particles interacting together. So our program in this course is going to be to take the first steps toward understanding why and how it is that these unique properties emerge when we have large numbers of particles together. Clearly, it's not possible to exactly solve the Schrodinger equation for something like 10 to the 23 particles. Although that's what we would like to do, it's just not possible. So we'll use various levels of approximation to deal with this challenge. And so I encourage you as we go through this course to ask yourself, what are the different approximations we're making at any given stage? Let me make one other observation, which is the first time I took this course in graduate school, I didn't really understand it or enjoy it. And I think that's because in this course, it can be quite challenging to keep track of all of the topics that come your way. So you'll see that we'll discuss a very large number of topics. It may not seem like they're related to each other, but they are. And I encourage you to, especially if you get lost or you're wondering why we're talking about something, try to zoom out and ask yourself, how does what we're talking about at any given time fit into this larger picture of understanding exactly how more is different? I don't think it's uncommon for people to struggle with this course the first time around, but if you stick with it, the effort is worthwhile. It's really a beautiful topic, and I look forward to exploring condensed matter physics with you this term.